Hey, welcome to episode 2 of Remaking Cave Story in Unity. So I have the actual Cave Story game opened up here, and we're just going to look at how Quote animates in this game. So as you can see, when he stays still and faces a direction, he has an idle animation, which is just a flat frame. And when he looks in either direction, that's what's going on. And if you hold up, then he looks up. If you jump and look down, then he looks down, but if you just press down while on the ground, then nothing happens. While he walks, a walking animation plays. When he jumps, there's one frame for while he's jumping, and then when he starts falling, another frame switches out for it. So yeah, as we can see, there's a couple different things we need to do. Number one, we need to make sure that Quote is facing the direction of his movement. So if he goes right, then he faces right, and if he goes left, then he faces left. And then we want so that if we hold up, then he looks up, so that way we can program that he can shoot upwards. And as you notice, while he's looking up, there's also two different frames for when he's looking up. When he's looking up to the right and when he's looking up to the left. Same for down when he's airborne. And then we want a walking animation that will play when Quote is walking. And we want jumping so that while Quote is airborne and he's moving up, then the jumping frame is being shown, and when he's airborne and falling down, then the falling frame is being shown. And if we do all that, then we should be golden. Okay, so the first thing we have to do is we have to give Quote some animations that we're going to be able to work with in a controller. So what we're going to do is let's make a new folder called prefabs. Open it up, make a folder inside there, call it player, open up player, and this is where we're going to keep everything of note according to Quote. So we'll drag in the player prefab right there. Then we're going to make him an Animator Controller. So let's give him an animator. Then we'll create an Animator Controller in here. Call it player Animator Controller. Open them up and drag that in there. Great. Now let's open up the animation window. Animation. Dock that in right there. Okay, great. So we're going to have to create a new animation clip. Alright, perfect. It's right here. So the first one we're going to make is idle. So idle is just going to be this frame. So here's how you create animations in Unity if you don't know. You're going to, or 2D animations. You're going to hit the red dot. Then you're going to make sure you have your object selected. Oh, you have to hit the red dot again. And then you're going to go to the sprite renderer, and then you can select whatever sprite you want, and that'll make it a keyframe in the animation. You have the diamonds here. That'll show you that that's a keyframe. So let's go over there, and we want this one. So that's the keyframe, and now if we hit play, it's just going to show that. So great. Now we're going to create another one called idle looking up. So here we're going to do pretty much the same thing. We're going to go type in my car, because my car is what all the Quote sprites are called. And we'll find it. It's 3. There we go. So now he's looking up. Let's create another one called jump looking, or just jump. First jump one first. Make sure to hit the red dot every time, otherwise it's not going to work. That's one of the things that makes Unity a pain in the ass sometimes. So jump is going to be this guy. Alright, great. Oops. Now we're going to create another one called jump looking up. Hit the red dot. Hit this. Type in my car. Jump looking up is right there. Yep. Let's create another one. Call it fall. Hit the red dot. Fall is going to be the one after jump. You can tell them apart because jump, his legs are kind of farther apart, and fall, his left hand is kind of back. And yeah, so that's good. Then let's create another one called fall looking up. Hit the red dot. default looking up is right there. Great. Then I'm going to create one called run. Now run's a little bit tricky because it's a multi-keyframe animation. So here's how you do that. You'll start by the first frame, which is going to be this. Then we're going to go to frame 10. Hit this. Go back, go to 20. Go back to this guy. Go to 30. Go to this guy. Go to 40. Go back to this guy. So it's a 5 keyframe animation, or 4 with a reset. So if we play it, looks like that. Great. Now we have to create the same thing. Run, looking up. So it's the same thing, but he's looking up. So make sure that you select a different frame and then the first one, otherwise it might not register as a keyframe. And you can always check if it registered as a keyframe by seeing if there are diamonds right here. All right. Now, go to, oh shoot. We have to make him looking up. So it's gonna be this guy. Go to 10. This guy. Go to 20. This guy. Go to 30. This guy. Go to 40. This guy. And now, if we play it, great. Now there's just one left. It's called idle looking down. And we only need one of these because if you're looking down, there's only one frame that could possibly be playing. So we hit the red dot. And you may be wondering why we're only doing these for one direction. And the reason for that is, I'll show you in a second. So that's it. The reason for that is we can actually, if we go to the player, you can actually flip the X like that in the sprite render. So there's no point to doing it like actually animating it, because then we'd have to make double the animations, and there's just no point to doing that. So yeah, this is the easier way to do that. Okay, so the next order of business is working on our Animator Controller. So let's open this up. And right now it's looking a little messy, so here's what we'll do. We'll just delete all of these. And so what we're going to do is we're going to create a substate machine and call it Locomotion. And we're going to set this to be or we'll just make that the default like that. Great. Then we'll enter it, and we're going to create 2 blend trees. First one is going to be called grounded. Second one is going to be called Airborne. Okay, so if we open up grounded, here's, oh, we need to make some parameters first. Okay, so the first parameter we'll make is called velocity x. Second one we'll make is called velocity y. Third one we'll make is called looking. That'll define if we're looking up or down. Fourth one we're going to make is a bool called grounded. And I believe that is all. Okay, let's open up grounded. And it's going to be a 2D freeform Cartesian. First one's going to be velocity x. Second one is going to be looking. And you're going to want 4. So the thing about grounded is that our looking value is going to go from -1 to 1. So -1 means you're looking down, 0 means you're just neutral, and 1 means you're looking up. So since you can't look down while you're grounded, what we're going to do is we're going to have velocity 0, 0, and then 1, 1, and then we're going to have 1, 1. We don't have to worry about negative looking because you can't look down. So yeah, it's going to be the corners, 0, 0, 0, 1, 1, 0, and 1, 1. So 0, 0, if velocity is 0 and you're looking neutrally, then we just want to play idle. If your velocity is 0 but you're looking up, then we want to play idle looking up. If your velocity is 1 but your looking is neutral, then we want to play run. And finally, we want to play run looking up. Great. And we can actually test this out by putting quote in here. We can pull the velocity up, and as you can see, when we pull the velocity up, it plays the run animation. If we pull the looking up, then he looks up. If we pull them both up, then he runs while looking up. Perfect. All right, now let's go to Airborne. So Airborne is a little bit trickier. It's also going to be 2D freeform Cartesian. So the first thing is going to be velocity y. The second one is going to be looking. Now, the tricky thing about this is that you can look down while you're airborne. So we're going to actually need 6 motion fields. 2, 3, 4, 5, 6. We're going to need 3 entries for when your velocity y is negative, because that means you're falling. And we're going to need 3 for when it's positive, because that means you're jumping. Then over here, we'll just have -1, 0, 1, -1, 0, 1. Okay. So basically how this is going to work is that when the velocity is up, then that means you're going to be playing your jump animations. When it's down, it means you're going to be playing your fall animations. Looking, when it's up, you're going to be looking up. When it's neutral, it's going to be just neutral. And when it's down, you're going to be playing the fall, the looking down animation. And the cool thing about this is that there's only one looking down animation, so we can just reuse that for multiple spots. So -1, -1. When you're falling and you're looking down, then we want to play idle looking down. -1, 0. When you're falling but you're looking neutrally, then we just want to play fall. -1, 1. When you're falling but you're looking up, then we want to play fall looking up. 1, -1. When you're jumping but you're looking down, then we want to play idle looking down. When you're jumping but you're looking neutrally, then we want to play jump. When you're jumping and looking up, then we want to play jump looking up. So if we play this, let's see what happens. If you hit looking, then he looks up. So velocity is working right, the feet shift. If you're looking down, then regardless, it's going to play looking down. All right, great. So now the last thing we have to do is we have to put transitions between these two state machines. So we're going to make a transition here, and we're going to make sure that this has no exit time and no transition duration. We want it to be instant. And this is going to happen when grounded is false. Grounded is going to go to airborne when it detects that grounded is false. And airborne is going to go to grounded when it detects, as you can probably guess, that grounded is true. And we also want to check that there's no thing. Don't worry about these errors. Let's actually go back and make sure that this, okay. Cool. Cool. So, the next thing we're going to have to do, so now we're actually going to code all of this, because right now, if we play the game, it's not doing anything. It's, it's not actually, because we have to, like, change these values inside code. So, what we'll do is, we're going to we're going to make a new class. So let's create a folder called MISC, and inside MISC, we're going to create a new C# script and call it general. All right, so let's open it up. First thing we're going to do is we're going to open up general, and general is going to be a static class, so we don't have to inherit from mono behavior. So what we're going to have in here is, actually outside of it, we're going to have a public enum called direction. Direction is going to be up, down, left, right, or none. And then inside general, we're going to make a public static helper class called direction to vector. And it's going to take in a direction, D, and it's going to do a switch with it, switch D. Case up, it's going to return vector 3 dot up, case, oh, we never define what type it is. You know, we could actually make it a vector. Nah, vector 3 is just easier to work with in Unity usually. Okay, so down, it's going to return vector 3 dot down, case left, return vector 3 dot left, case right, return vector 3 dot right, case none, return vector 3 dot 0. Default. I can actually put that in there. So it defaults to returning 0. Okay, let's see if there are any compile errors. Oh, shoot. Name left, right? What is the error with that? Oh, probably have to say direction dot. It's kind of dumb, but whatever. That's what happens. Okay, great. Alright, sweet. Now we open the player class, and there's a couple different things we're gonna have to do. First order of business is we're gonna need some references to the animator and the sprite render. So let's just say animator, animator, and sprite render, sprite render. Oh, that should not be capitalized. Okay, and we'll access them inside the start function. So animator equals get component animator, and sprite render equals get component sprite render. Cool. Then, okay, we're gonna want two different variables. Direction, and bool facing right. So you might think that having a boolean for facing right is redundant if we already have direction, but remember, you can be looking up but facing right. So direction is going to be your like aiming direction, like if you shoot, then which direction the bullet is going to go. Facing right is just going to define for the animation whether you're facing to the right or facing to the left. We are going to figure out what these values are inside the getInput function, and then we're going to actually apply them to the animator inside the sprite render in an animation function. So let's create a function called animation, and we'll put that over here. Okay, so let's define all the parameters that we had from before. So if we open up the animator class, velocity x, velocity y, looking and grounded. So velocity x, so anim.setFloat, animator.setFloat velocity x. So what do we want to set it to? We want to set it to movement input dot x dot set float velocity y to ff dot sign of velocity dot y. So what do these do? So velocity x, movement input dot x, that's just going to give us like whether we're moving left or right, so that's perfect. Velocity y, we're getting the sign of the velocity, and this is sign as in like plus or minus, not sign as in like, you know, trigonometry sign, because we just want it to return +1 if we're going upwards, -1 if we're going downwards, and 0 if we're not moving. Great. We want to set this to mathf.absolute value movement input.x, because remember, we don't want this to be negative because we're only animating one direction, and we're going to set like the direction, quote unquote, using the sprite render. And that reminds me, we have to do that. Okay, so sprite render dot flip x equals facing right. Because all the animations are facing left, we want, if we're facing right, then we want it to be flipped. And if we're not facing right, then we don't want it to flip. What's the next thing we have to do? Grounded. Animator dot set bool grounded. And we're just going to use controller dot collisions dot below. And that's just a bool that's inside the controller 2D class. You don't have to worry about it. That's like part of the backend stuff. You can look into it if you want, but that's just going to be our general grounded thing. Okay, and the last thing is looking. So looking, we just want it to return the direction that we have. Or we want it to get the direction that we have. So how we want looking to work is we want it to return 1 if we're looking up, -1 if we're looking down, and 0 if we're neutral. So how are we going to do this? The best way to do it is just to use the function that we just created, the direction to vector, and get the y value from it. So say, okay, you know what? Let's actually just make this a vector too. And then return vector 2 on all of these. Yeah. Okay. So we're going to say general dot direction to vector. Then we're going to put in our direction. Okay. See if we have any compilers. Okay, we have 2. The best overloaded for set float has some invalid arguments. Okay, what line is that on? That's on line 60. Oh, right. We forgot to set it to y. And yeah, let's see. Okay. So now that we have the animation done, all we have to do is we have to actually set those values inside get input. So what are we going to do? Okay, so the first thing we want to do is we want to check if we're moving. If moving. So how do we do that? If movement input dot x doesn't equal 0. So that means that if our x input doesn't equal 0, then that means we're moving horizontally. Oh, I should probably specify that. Then what we want to do is we want to set our direction based on how we're moving. So we're going to say something like direction equals movement input dot x is greater than 0. Direction dot right. Direction dot left. If you don't know what this is a ternary operator. So what it does is like it has a conditional at the beginning, and if this conditional is met, then it returns the first thing, and if it's false, then it returns the second thing. So it's going to check if movement input.x is greater than 0, and if it's greater than 0, that means we're moving positively, we're moving to the right, so then it's going to turn right, and if it's moving the other way, then it's going to go to the left. Okay, and we want to do the same thing for facing right. So facing right equals movement input.x is greater than 0. Great. Then we want to kind of check the same thing, but for movement input.y. So we're going to do kind of the same thing here, but it's going to be slightly different because we need to account for if you're grounded. So we're going to say float vertical aim factor equals movement input.y. So that's going to be the up and down input, right? Now we want to check if you're grounded. So if controller.collisions.below, then what we want to do is we want to clamp it so you can only look up. So then we'll just say vertical aim factor equals mathf.clamp 01 vertical aim factor. Here, I'll just put that on a new line actually to make it a little bit more readable. Great. So now we have a vertical aim factor, which is basically movement input.y, but if we're grounded, then it's not going to allow it to be negative. So then we're going to do the same thing like here. If looking vertically, so instead of movement input dot x, we're going to say vertical aim factor, and direction, I'm going to say that, and there's no facing for this, so I'm just going to have that. And so vertical aim factor is up, and I'm going to say up. It's down, we're going to say down. Great. All right, sweet. Let's see if that compiles. All right, now let's test it out. When I press a key, then it stays locked like that. And I'm not holding up right now. So let's see if we can debug that. Oh, I know what the issue is. It's that we need to reset the direction at the beginning of every frame based on the facing direction. So we'll just say direction equals facing right, direction dot right, direction dot left. So now if we open this back up and play it again, I don't know why my viewport got all messed up. No, whatever. All right, sweet. It's working perfectly. It's working just as intended. So the walk animation for quote is a little bit slow, as you can see if we like move some blocks here, and then if we play it, you'll notice that it's moving a little bit sluggishly. So all we can do to fix that is just go to animation, and then under the grounded blend tree, just change the run and run looking up speeds to 1.5. Excuse me. And now if we play it, we'll notice that he's moving at the right speed for the game, and yeah, it's looking great. Also, I went back and checked and realized that I mixed up the fall and jump animations. So what we'll do is we'll just rename those. So name this something random, and then rename jump to fall. Rename jump looking up to fall looking up. I just named this something random so that it didn't try to overwrite the other one. And then name this back to jump. And then name this to jump looking up. And if we go to the animator, go up to Airborne, then we'll just change them. So jump, make that fall. Jump looking up, we'll make that fall looking up. Fall looking up, we'll make that jump. And jump looking up. Great. So now, if we play it, now it's actually, for real this time, perfect quote animation. Sorry about that. But yeah, now it's perfect, and we are great. Thanks for watching. I'll see you guys next time, and I'm not sure what we're gonna do, but it might be guns, it might be mapping, but yeah. Anyway, make sure to subscribe so you're notified for the next episode. Thanks for watching, and I'll see you guys next time.